Welcome back. In this video, we're going to talk a little about how to find the average value of a function over a particular region D. This is kind of generalizing the ideas that we learned in Calc 1 for average value. So that's actually where we're going to start. We're going to remember what we saw in Calc 1. So for a function f of x on an interval from A to B, we saw in Calc 1 that the average value of f is given by one divided by the length of the interval times the integral from A to B over f of x dx. Okay, so integral of f divided by length of interval. So we're going to take this idea and kind of try to extend it into higher dimensions. The thing with higher dimensions, though, is that we're no longer looking at really necessarily length of an interval for our regions. We're looking at areas or even volumes or things like that, because you're integrating over cubes and squares and rectangles and things like that. So in higher dimensions, and for our purposes, the average value of a function f over a region D is given by, it's something that's really quite similar. And I'm actually just going to write this out in words instead of giving notation, because depending on whether you're working with like a triple or a double integral, the notation varies, but the idea remains the same, and that we have to take the integral of f over our region D and then divide by the size of D. Okay, so we have the integral, which is the same idea as what we had before, and then the size of the region is corresponds to the same idea as the length of the interval that we're working with. So, I mean, I guess this isn't really like a formula per se, but this kind of tells you exactly what you need to find, and then you divide the integral by the size of the area you're working with. So let's go ahead and work an example. We will find the average value of f of x, y is equal to 1 on the domain D equal to x, y, such that 0 is less than or equal to x less than or equal to 4, and y is bounded by 0 and 3. Okay, so remember that we are looking for integral of f over the size of D for our average value. So first thing we're going to compute is the integral of f over D. And the way that we're going to find that is, well, we want to take into account as many variables as we have. So we have two variables, so we're going to look at a double integral of f of xy, that's our function that we're looking at, and then dy dx is fine. It really doesn't matter what order we're going in here in this particular case. So for dy, we have to give the bounds of integration for that, and the bounds here are really just given by these guys here. So when I say that we are integrating over a domain D, just keep in mind that that's going to give you the boundaries that you're going to use for this integral. So we're looking at dy here first. So we want the y bounds, that's going to be 0 to 3. And then same idea here for dx for the outer one, 0 to 4. So we have the integral from 0 to 4, integral from 0 to 3 of 1 dy dx. And I can just split that up. Oops, dx. Integral from 0 to 3 dy, like so. And so I have x evaluated from 0 to 4 times y evaluated from 0 to 3. And that's just going to be equal to 12 because we're going to have 4 times 3. Okay, So after that, we just have to find, in this case, size of D, that's just going to be given by area, because this guy right here is just a square, or I guess it's a rectangle. It's a 4x3 rectangle. So area of D, well, we have 4 in the x direction times 3 in the y direction. So the area is going to be 12. So our average value is equal to 12 divided by 12, which is just equal to 1. So pretty straightforward. All you got to do is compute the integral and then divide by the size of whatever domain you're working with. Let's do one more. In this example, we have a function of 3 variables. So f of x, y, z is equal to x cubed y squared z. And the domain that we're working with is points x, y, z, such that x is between 2 and 4. 1 less than or equal to y less than or equal to 3, and 4 less than or equal to z less than or equal to 6. Okay, great. Again, average value is equal to the integral of f over d, and then that's going to be divided by the volume in this case, because we have it's a cube or a rectangular prism, if you will, sides 2 by 2 by 2. Oh, I guess it is a cube. Okay, volume of d. Okay, so first thing we're going to do is find the integral. So this is going to be a triple integral because there's 3 variables that we're working with, f of x, y, z. I don't know. We'll just do x and then y and then z. So x is bounded from 2 to 4, so that's dx. Y is from 1 to 3, and then z is from 4 to 6. We actually already computed this integral in another video, so I'll leave those steps. If you need clarification on those, you can, or actually here, I'm going to write out explicitly what this function is here, but we actually already did this. X cubed y squared z dx dy dz. And what you get out of this is going to be 5,200. And again, the steps to getting there are contained in the previous video on integrals in higher dimensions. So that's the integral of f over d. Now we just need the volume. And that's going to be 4 minus 2 times 3 minus 1 times 6 minus 4, because this is the dimension for the x, y dimension, and the z dimension all multiplied together. You're going to get 8 out of that because it's a cube with sides of 2. And so then our average value is equal to 5,200 divided by 8 all over, or yeah, 5,200 divided by 8, which is going to give us 650. And that's pretty much all there is. It's really actually a pretty straightforward process. Again, it's really, really similar in concept to what you learned in Calc 1, except instead of talking about line segments, now we have to divide by the whole size of whatever domain we're working with. So hopefully that's helpful, and I'll see you next time.